Again, thank you all for taking time out of your busy days. If you should have to leave suddenly in the middle of the webinar, we will post a recording of the entire session, and we will also have transcribed content on this subject on our website. We'll also turn it into an ebook that will be available in a week or two, something like that. Yeah, we'll try to have the ebook ready for NAB. So if a customer calls or if you have some emergency, don't worry. We'll send you all of the recording. I see some friends here have already connected. Hi, Tom. Thanks for logging in. How's the weather in Philly? I see my colleague Cindy is logged in. Snowing, oh man. So it's snowing in Philly, huh? Cindy might have similar weather up in Grass Valley. So there's still a few more people signing in. I'll give it one more minute, then we'll start. Got a pretty good turnout. Thank you, guys. Give it another few seconds. We'll start at 11:01. We got a few more seconds. I can see on my screen people logging in. Thank you for joining. And yeah, I mean, feel free to step away. Like I said, we'll record this, so we'll have you guys covered. This is a great topic. I presented part of this subject at the recent, it was the February Washington, D.C. SMPTE chapter. I spoke about this subject as well as the live PD TV show that we're doing with our bonded cellular technology. So both subjects were very well received. Okay, it's 11:01, folks. So I'm going to get started. You guys say you can hear me, so I'm going to jump in. For those of you that don't know me, I'm Jim Giacchetta. I'm the co-founder, EVP of Engineering and CTO of Vidovation. I've been in the television industry going on 30, 35 years. Earlier in my career, I worked for my father's company, Multidyne, that he started after working at NBC for 12 years. Then my brother now runs Multidyne, and I now run Vidovation in Lake Forest, California. So today we're going to talk about some of the advancements in wireless video, wireless technology. So for years now, we've been asked for a wireless system with low to minimal latency. Now, there are systems out there today, and Vidovation offers some of these other types of technology that have close to zero latency or 3 milliseconds of latency. The systems are inexpensive, but you do sacrifice video quality. So these other systems are heavily encoded. And to me, there's an argument when people say encoding is not compression. Well, to me, heavy encoding is really a crude form of compression. It's kind of an unintelligent form of compression. So we've been asked for kind of a blend of both worlds, maintain broadcast quality while offering a subframe or very low latency. And I'm going to discuss this technology today. So let me see here. Get my slides to move. There we go. So, you know, the challenge. So as I mentioned, you know, the challenge was to get that latency as low as possible. And the current state of the art with a COFDM or OFDM system right now is 7 milliseconds, and that's technology provided by ABonAir. They're a recent Vidovation partner. They have an amazing product. They have some amazing technology. So, you know, most of you guys probably know why low latency is needed, but for those of you that are not familiar, you know, applications such as sports, cinema, if you're piloting a drone, or if you're controlling a camera, if you're controlling the iris, if there's latency in the link, you know, you're controlling the video from a few seconds ago. So you know, it's very difficult. There's lag when you're controlling, or if you're remote controlling pulling focus, you know, the director is going to think you're bad at your job. You're not able to keep the camera in focus because there's this latency in the wireless transmission. I mean, ideally, zero latency would be the most preferable, but the ABonAir system offers 7 milliseconds, which is about half a frame or less than half a frame. Let me ask you guys. I got some poll questions for you guys. Let me ask you guys a couple of questions. So, how many of you guys out there are using a wireless camera-mounted system of some sort? You know, do you like the gentleman in this photo here? Do you have a sports venue, a studio? Are you part of a news crew, ENG crew? Are you using some sort of a wireless link mounted to a camera? Just to kind of get a feel for where you guys are at. Let me see here. I think I can post the results here. I'm a little rusty at this, but let's see here. I think I can post the results. Well, maybe I'm not sure how to do it. I can tell you guys what the results are. So 39% of you guys say you're using some sort of a camera back wireless camera system, and 61% of you are not. So our biz development team may reach out to you guys, and you can tell us more about the camera systems you're using, and if you're interested in a lower latency, maybe we can help you guys out if appropriate. So out of you guys that are using a wireless system, what frequency bands are you using? I'm just curious. You know, we see a lot of broadcasters have a license to use the 2 gigahertz BAS band. You know, this is a license that, you know, you have to be a television station or a television network of some sort to get that type of license. 5 gigahertz licenses are very common because there is no license. The 5 gigahertz band is very popular because no license is required. Some of the times, some of the negatives though are the 5 gig band is rather crowded, so there can be problems with interference. I'll talk about this later, but the ABonAir product, if you buy the 5 gig band product, it will frequency hop. It'll jump channels, and it has channels above and below the Wi-Fi band. It'll start at 4.9 gigs and go all the way up to 5.9. So in most applications, 5 gigs is adequate. ABonAir does have a 7 gig solution, and we've been getting a lot of requests for 7 gig recently. I threw in 60 gig. Vidovation makes a 60 gig product. to transport uncompressed video, both video, audio, and then we have an Ethernet solution. So I threw that in there. And the NHL goal cams currently are based on the 60 gig technology. So I might just be a little rusty at this. I don't. There used to be a way to publish the results of the webinar of the little poll, but 13% of you guys are using the 2 gig BAS, 19 are using 5, 6% are using the 7 gig band, and 13 are using 60, and 56% are not using anything. So I thank you guys for contributing the statistics. When we publish this webinar, we'll put those statistics in the document so everyone can see. So I think you get the idea why low latency is important. And unlike some of these other systems that are out there, we're not sacrificing video quality to get such a low latency. The ABonAir product is able to compress the video, to quickly compress the video, transport the video, decode it, all within less than half a frame or 7 milliseconds, which is amazing. So how do some of these wireless systems differ? Some of you guys out there might be familiar with COFDM type systems. So COFDM, are you guys seeing my screen? Hold on, I think because I did the webinar. Here we go. Let me hold on one second. Just bear with me. I think because I did the poll, it disrupted the slides. So I was just showing you this slide here where, you know, it's 7 milliseconds video quality. So here I'm on slide 2. So now the slides seem to be working. So those of you who are familiar with wireless systems, you know, you have the RF link, you have the RF channel. So you know, that's defined by the FCC, and you're given a certain channel bandwidth, you know, 20 megahertz or a 40 megahertz channel. And what wireless systems do is they make use of that channel. So one technique to maximize the throughput on a given channel is using different modulation schemes. So one simplistic scheme is to use QPSK or quadrature phase shift keying. So what does that mean? So basically, it's sending 2 bits per symbol. So it's like having a 2-bit wide bus going through the wireless link. So for every symbol or for every word that goes through, the word or the bit is 2 bits wide. The bus is 2 bits wide. Then you have higher order modulation where you have 16 QAM, you know, quadrature amplitude modulation. So essentially now we have 4 bits per symbol, or we've doubled the bandwidth. Then you have 32 QAM, 256 QAM. So, you know, the common question one might ask is, well, why not use 16 QAM all the time? So there's everything in engineering, there's pluses and minuses, there's trade-offs. So in the case of advanced modulation schemes, such as like 16 QAM, they become more sensitive to noise or interference. So I don't know if you guys have ever seen it. I don't have a slide for it, but if you've ever seen a QAM signal on a scope, I'm sure you've seen the SDI eye pattern. A 16 QAM will have 16 eye patterns, like 4 rows of 4 little eye patterns on the screen. And if the environment is noisy, or you're at the end of your link budget, or there's interference, the eye patterns start to close, they start to interfere with each other, they blend into each other. So it's quite a complex signal. So what the ABonAir product does is it's got a spectrum analyzer, and it's always analyzing the RF environment. So if there's interference, if there's an issue, it will actually change modulation scheme depending upon the wireless environment. So the unique thing compared to other wireless systems is that it can adaptively change the modulation. You guys out there that are using some sort of a wireless system, if you're using a COFDM system, you can go into the setting and change the modulation, but it's fixed. So you'd have to actually stop the transmission. I'm not getting a great signal, so I'm going to stop the transmission and change from 16 QAM to QPSK or vice versa. What ABonAir does, and as far as I know, they're the only ones that do this, is it's adaptive. So it'll change the modulation scheme depending upon the environment. So what are the differences? So you guys may have heard OFDM. That's been around for a while. The more modern version is COFDM. There's a lot of similarities, or in a lot of senses, they're exactly the same. The coded part, or the C part of COFDM, really has to do with forward error correction, or the coding of the data as it goes through the conduit, or as it goes through the wireless link. So your typical COFDM system that you guys might be using now, you see forward error correction, which is great, but you sacrifice redundancy for payload. In other words, forward error correction adds overhead, so less of the available bandwidth goes to video or video quality. So FEC is kind of a crude way of anticipating errors, sending redundancy through the circuit, whether it's needed or not. So if the link is doing very well, and you send all this forward error correction through, you could have used some of that bandwidth for better video quality or higher bitrate video. And again, in some of the COFDM systems that are out there, you can turn FEC on and off, or you might be able to increase or decrease the FEC. But again, it's manual, so somebody's got to stop the rig and make these changes, assuming that the changes can be made at all. Another limitation is the fact that all the COFDM systems that are out there now are simplex. So forward error correction is great for sending data and forgetting it. You send and forget. The forward error correction, you send some overhead with the payload. Forward error correction will automatically recover a certain number of errors on the receive side in the receiver decoder. And what is OFDM or COFDM? It's hundreds or even thousands of small, low bit rate little RF carriers. And one of the nice things of OFDM or COFDM technology is, because you have these low bit rate carriers going through the air, it's very conducive to bouncing around corners, bouncing off of obstacles. You need line of sight or near line of sight, but you can go around the corner of a building because you get bounced off of adjacent buildings. So COFDM, I'm sure you guys have taken advantage of some of the positives of the technology, bouncing around objects, that sort of thing. So COFDM, it's the most common form of transmission and modulation for most high-end wireless systems. Systems starting at 15,000 to 100,000 are probably using some form of COFDM. Most COFDM, just by the nature of the technology, is limited to an 8 megahertz bandwidth. In the 5 and 7 gig bands, we have 20 megs available to us. So a big chunk of bandwidth is wasted, not utilized. COFDM, just the chipsets, the way it works, only supports 8 megahertz. Some manufacturers take the concept of they run two COFDM systems side by side, an 8 meg and an 8 meg, to get 16 meg throughput. but I don't think they can utilize the full bandwidth in those types of scenarios. So some manufacturers have done some trickery to use more bandwidth through the circuit. So how does ABonAir do it? So they use a proprietary OFDM. So that you notice the C is removing, the coded is removed. Now they do some coding, they use some forward error correction, or the forward error correction is dynamic. So the ABonAir product has a spectrum analyzer running in the background, analyzing the environment. It'll pick a channel that's quiet. If the channel is still a little bit noisy, we only have one channel available to us, it's okay, but it's not perfect, it'll turn more of the forward error correction on. Then it takes a more educated approach where it uses ARQ, or automatic re-requests. So in any kind of an ARQ system, whether it's bonded cellular or it's a telecom encoder, you need a bidirectional link. So ABonAir is one of the only systems out there, if not the only system out there, that has a full bidirectional radio for the video transmission. They might have other bidirectional secondary radios for camera control and intercom, but ABonAir has one radio with up to 50 megabits per second throughput bidirectionally, and the transmitter and the receiver are constantly talking to each other. So there's a lot of analogies between how the ABonAir product works and the bonded cellular. So the encoder in the transmitter is a variable bit rate encoder, or VBR encoder. So based on the quality of the RF link, the encoder will go up and down in bit rate. Based on the level of encoding or modulation that we can achieve, whether we're QPSK or 16 QAM. So based on the throughput, it's constantly adjusting, constantly adapting. Then if the decoder senses that we've lost some packets, it will actually re-request a transmission from the transmitter and only request packets when needed. So by not flooding the connection with unnecessary forward error correction bits, it only re-requests those bits that are missing. So more of the bandwidth can be assigned to the video. So out of a 20 to 40 megahertz bandwidth channel, we can achieve up to 50 megabit per second throughput. And 50 megabits video looks fantastic at 50 megabits per second. So again, it varies depending upon the link and the RF conditions, but in a clean environment, the throughput can approach 50 megabits per second. So let's talk about how is this done. So the transmitter and receiver, they have two antennas. So it's a MIMO communication. It's a 2x2, 2 in, 2 out. Multiple in, multiple out. It's a 2x2 MIMO setup. So OFDM sends these hundreds or thousands of carriers. So they're redundantly sent over both antennas, so you have diversity in that respect. The system is secure. The communication between the transmitter and receiver is encrypted. Everything is automatic and dynamic. So if some of you out there are afraid of all this technology I'm throwing at you, modulation, forward error correction, adaptive bit rate, or variable bit rate, it's all done automatically. You just turn the unit on, it finds the best channel, and it just transmits. Now, if you're in an environment where you need to do some frequency coordinating, in other words, if there's a lot of vendors or a lot of photographers using the 5 gig band at a major sporting event, let's say, it may be mandated that you guys do some frequency coordination. And in that case, the automatic frequency hopping feature can be overridden, and the and a channel can be selected by default. So in those situations, the frequency coordinate may not want your unit hopping channels because you might step on somebody else's channel theoretically. But in most cases, you're going to want to run the unit in the automatic frequency hopping. So as I mentioned, the units pair with each other. The ARQ, or the automatic retransmission of drop packets, happens automatically. ABonAir feels it's a more efficient use of the bandwidth, as I mentioned, using relying more on ARQ instead of relying on forward error correction. Now, mind you, some forward error correction is used, or the forward error correction may change, but everything is adaptive. Everything is adaptive. So let me see. There we go. So by using this retransmission algorithm, or relying on ARQ more than forward error correction, statistically, 2 times up to twice the bandwidth can be used for video. So theoretically, your video quality could be 2 times better than a competing system. Where another system maybe is using 8 megabits per second throughput, the ABonAir could be doing 16 megabits or even as high as 50 megabits. You can see here, most systems are set up to have, let me see here, can I do my little pointer? Yeah. Most systems are, the FEC is arbitrarily set to 25% or even up to 100%, whether it's needed or not. And then the typical bit error rate on an OFDM system is 1%. So the argument is, if you're only dropping 1% of packets, why do I need 25% FEC? But there could be conditions where the bit error rate does get up into double digits, and the ABonAir would then kick in a little bit more FEC combined with ARQ. So it's kind of a crude approach to just blindly assign 25% FEC when it may not be needed in most cases. Or then if conditions change, wouldn't it be nice to be able to turn it off, or have it turned off automatically for you, such as the ABonAir? So we never know the time and the location of the errors, so we have to forcibly put forward error correction across the whole transmission path. Whereas with ARQ, we're picking and choosing. We're only asking for those packets to be replaced that are actually lost. We're not crudely throwing bandwidth away on FEC. So hopefully that makes sense to you guys. And what facilitates this ability comes back to this again. You couldn't do it unless you had a bidirectional radio. It's just like bonded cellular. Bonded cellular, the encoder, the transmitter, the transmission path, the decoder. It's a closed loop. The decoder is talking to the encoder. It's making adjustments for bandwidth. It's very clever what ABonAir has done. They're the first to implement this type of technique in a wireless camera system. So with the full duplex, every bit is acknowledged as to whether it was received or not. Again, with a simplex radio, you throw on some forward error correction crudely, and you send and forget. You from the transmitter's perspective, you send it and hope everything works out. Whereas ABonAir takes a more intelligent approach, and they only send those packets that are needed. So they make more efficient use of the available bandwidth. Another limitation on these other COFDM systems that you guys may be using. So I mentioned the changing the modulation. You have to stop the unit and change it. All the other units that are out there have a constant bitrate encoder. So what does that mean? That you know, if you want to run your COFDM unit at 8 megabits per second, some of them may even go up to 10 megabits per second, you have to set your encoder at 8 or 10 megabits fixed. If the pipe should close, if the link should fall below the 8 megabit threshold, the communication is going to stop. You're going to lose the whole payload. So again, you can change the encoder bit rate on these other COFDM systems, but it's a manual change. It's not automatic. So this limits the distance. This limits the link budget. You know, I think most of you would rather have a 4 or 5 megabit signal coming through than no signal. You know, if you got to the fringes or the end of the link budget of your wireless system, you'd rather have a slightly reduced a bit rate or slightly reduced quality than no connectivity at all. So the ABonAir system, because of these techniques, we're able to go 3 kilometers or more than 3 kilometers or more than 2 miles, whereas other systems would be hard pressed to reach those distances, or they could reach those distances, but you'd have to manually make tweaks to the settings. You'd have to stop, go in, take 15, 20 minutes to make those changes, restart the transmission. Oh, wait, no, that didn't do it. I have to make other changes. Whereas this is just all seamless, constantly in the background. And mind you, it's making all of these decisions, all of these automatic re-requests for lost packets within that 7 millisecond window. The buffer on the receiver is only 7 milliseconds deep. So if a packet is missing, the decoder requests the missing packet within that 7 millisecond window, which is amazing. So you know, what does this do? So it makes the traditional COFDM system limited in distance. It limits how you can move your transmitters and receivers around. You know, the ABonAir is going to be more forgiving for some partial line of sight obstructions. It's gonna be less susceptible to interference. If interference should all of a sudden creep up, the ABonAir will either hop channels or change bandwidth, change modulation, change bitrate, all automatically. The user, the operator, will never even know. So the ABonAir is taking the 20 or 40 megahertz channel bandwidth that's been given to us, and it's optimizing that to use up to 50 megabit per second throughput, which is unheard of. Again, that's under ideal circumstances or maybe when you're closer. But as you get to the end of the link budget, the unit will automatically adapt to those conditions. So it's quite an amazing product. So there'll be some new introductions from ABonAir that we're not at liberty to discuss before NAB, but this product right now is using tried and true adaptive bit rate H.264 encoding and decoding. So, you know, I hope some of you are not scared by all this. So it sounds like there's a lot of moving parts, you know, all these automatic things. It just works like magic. It all happens seamlessly in the background. The video is perfect. It doesn't stutter. Everything just happens. It's just very easy to set up. ABonAir also takes the approach of including, if you buy a fully loaded system, they include all the accessories. So you can see here, it comes with a very high quality headset. There are options for intercom. There's options for paint and camera control. So a video engineer in the truck or in the control room can be controlling the camera, can be controlling paint, the iris control, the black levels, etc. The bidirectionality of the radio is very conducive to having a bidirectional IFB or intercom, and also gives us the ability to have this bidirectional paint control. And the system is very easy to use. You just turn it on and everything goes. Another nice thing too is that, you know, one complaint we've heard from traditional COFDM is that when you do want to make changes, you got to do it from the transmit side. Well, the photog is busy getting his shot. He doesn't want to go in and have to change modulation, change bit rate, et cetera, et cetera. The ABonAir is all automatic, so you don't have to worry about that. But then if you did want to assign a fixed channel, or if you were doing frequency coordination, the camera op doesn't have to worry about it. It's all done from the base station. So there's a dial on the front panel of the base station, and there's a display, and you can cycle through. One of the choices, the first choice is auto, and then you can cycle through and pick the frequency automatically. So another nice feature of this technology, the way it works is kind of analogous to how cell towers work. It's an all digital system. So even the interconnects are digital, and digital over fiber. So you don't have to use bulky, heavy, expensive RF cables to connect your and distributed antenna system. So you have these little boxes, they're called FCEs, or fiber coverage extenders. So what they do is a single base station will cover a single area. If you want to cover multiple areas, so in this picture we got a football stadium and then the basketball arena. So this is indoors, this is outdoors, and they could be up to 20 kilometers away. A college town, the football stadium could be on one side of town, the basketball arena could be across town, could even be in another state. The fiber optic link between these could be more than 20 kilometers away. So you could have a production truck in the middle or a control room in the middle. So whether you're a broadcaster and you want to shoot untethered in different studios, you could have FCE in each studio. You could have an FCE at each venue. And then they're all hooked together with inexpensive single mode fiber. So you don't have all those bulky cables like I said. And the unit, if you're roaming, so say you take the camera rig and you want to do some do some tailgating, get some coverage out in the parking lot. Maybe these antennas, you roam a little too far, the unit will then jump to these antennas. So the FCEs can be daisy chained together. So for example, in a football stadium, we get asked this a lot. I want RF coverage in the bowl. I want RF coverage in the tunnel. I want RF coverage in the locker room. I want RF coverage in the press area. So if some of these locations have a 6-foot thick concrete wall in between them where RF won't go through, you could have an FCE device in each of these locations, and they can be daisy chained together and home run back to the base station, which could be 20 kilometers away. So it's really amazing technology. It's quite magical how easy it works. So here's the little box. This is what the FCE box looks like. The antennas are not plugged in though, so the antennas would plug in here. We have omnidirectional antennas, sector antennas, and then you have a fiber optic port in and a fiber optic port out. So this particular box is a loop through. So you could come in and then go to another loop out and go to another FC and daisy chain them together. And then it's got a 4-pin XLR for DC power, AC to DC power. So, these boxes will use, you can use existing fiber optic infrastructure or lay down some dark fiber to set the system up. And you can go much longer distances than you can with bulky coaxial cable. And fiber is a lot less expensive than long runs of bulky coaxial high frequency cable. So this is a really nice system. And then, of course, the video, the camera control, the CCU, tally, and intercom is all passed through this FCE fiber coverage extender. The whole system is compatible with it. Here's another way of looking at it. So you see how they're looped together. There's multiple ports on the base station. So this is what the base station looks like. Now, if you want to use the base station alone, the base station has RF outputs, RF jacks on the back for antennas. So if you're doing a simple system where you don't need the FCEs, you can achieve that with just the base station alone. There's also a portable version of the receiver, which looks very similar to the transmitter in size. It's kind of a similar shape similar shape and size. But most customers buy the, the portable transmitter, the camera mount transmitter, which is available V-Lock or Anton Bauer, and then a base station. And then we have kits that transmitter receiver, or transmitter receiver and an FCE, and then of course you can buy extra FCEs as you need them. You can add them, and you can see how they loop together. They loop through. And the ABonAir system, it's one of the Achilles heels of wireless systems is getting the compatible camera control. We haven't found a camera system yet that ABonAir is not able to support. Some of the newer Blackmagic cameras, they're working on support for them as well. So basically what you need is, in order to get the camera control to work, we have to provide the appropriate cabling. So pretty much all it depends on is having the cables with the right types of connectors for the different types of camera control. One type of camera control does include a little box, a little conversion box to do some signal format conversion, but that's included. That's included. So any CCU or RCP that you might be using is compatible with the ABonAir system, and you can see here the camera control connects to the base station. The base station probably would be in master control, and then you'd run a fiber out to your multi-zone FCE receivers, and everything is seamless. Everything works perfectly. And then, like I mentioned earlier, there's options for the intercom. Another cool thing with the intercom, you get this little belt pack. So you see here, you have an intercom call. You got an alert button or a talk button, and then you got a volume control. You can control the side tone. This nice headset is included. So you can see here, everything this Photog's got on this headset is part of the kit. Assuming you buy the fully loaded kit with the transmitter, base station, intercom, and camera control. It looks like this gentleman, yeah, he's got the camera control plugged in. So you see this Y cable comes out of a data port. One of them is going into the camera, so that's probably the control, this control connection, something like that. And then this cable is looping down. It must be like going around his back. Oh, he's probably going down to the belt pack and then coming up to his headset over here. So he has full control. If the director gets too loud in his ear, balking at him to get his shot, he can turn him down. So the integrated belt pack is part of the system. You got IFB for program audio return. What some customers will do is they'll use a separate wireless link from the camera rig to send IFB to, if there's a journalist, if there's an interviewer, they can have the journalist with a wireless microphone and then a wireless IFB, so the talent can then get a feed from the camera to get the program audio in their ear. That part would be separate, but we see a lot of our customers do that. The intercom system is very flexible. It will support 4-wire, 2-wire. It will integrate with virtually every intercom solution. The intercom bridge is analog, so all intercom systems. We haven't gone fully digital yet, so as long as your intercom system has an analog in and out, that can be bridged into the ABonAir base station to connect the intercom. And then, as I mentioned, just about every version of paint and camera control, Sony, Panasonic, Ikegami, Grass Valley, Hitachi, and more, throw Blackmagic in there now. They can support all of that. So all of this capability is packed into this system, and you're going to say, oh wow, this system must be $100,000. This fully loaded system is easily half or a third the cost of a comparable system. It has far less latency. It has far more range. So it's kind of a no-brainer. The technology is amazing. The latency is very low. It's jam-packed with features. We have quite a few demo systems in our inventory, so we're eager for you guys to, if you're interested in this technology, you really got to see it to believe it. It is an amazing product, an amazing technology. So to summarize, not to be overly redundant, the 7 milliseconds. So we're able to finally able to give our customers that 7 millisecond or that subframe or less than half frame wireless latency that they asked for. This way, if they're getting a shot at their stadium, if they're doing a kissing cam, or more importantly, if a photog is on the field, latency usually comes up during the national anthem. There's a gal or a guy singing the national anthem, a photog goes on the field with a wireless camera, and it's like you see in the video, oh, say, can you see? Oh, say, can you see? So it's awkward, even to consumers that are not technical. If the latency is bad enough, they sense that something's wrong, something's not right. So 7 milliseconds is barely perceptible. We'll have the system on demo in our booth at NAB. We're in booth C6906. Let me see here. I have a little message to send to you guys. Let me see here. If you guys want a link to the product, I just sent you a link through the webinar. So yeah, there's systems out there that are sub 1 to 3 milliseconds, but they're heavily encoded. And for some of our more price conscious customers, that's a very popular product of ours. But if you compare the two products side by side, you would see that the heavily encoded system, the video quality is much softer than the video quality in something like this. So we're able to give you that 7 milliseconds latency and still maintain broadcast quality and have a H.264 quality encoding at up to 50 megabits per second, which is quite amazing. The video quality looks fantastic. And then another Achilles heel too is like some camera control systems could be $10,000, $12,000, $15,000 separately. Intercom is not often available on some of the more inexpensive systems. So ABonAir is able to offer that as well, and all at an affordable price. So that's kind of wraps it up for today. If you guys have any questions, I can show you the, let me bring up the product page. I just texted you, I just chatted you guys a link to the ABonAir product. As I mentioned, we'll have it at NAB Las Vegas in a couple of weeks. Let me see here. You guys had some questions here. Let me see. Just pardon me. I'm all thumbs with the questions here. Let me see. How do I pop that out? Oh, here we go. Sorry about that. So let's see. Oh, what camera control cable length restriction to the base station? That's a great question. I'm not aware of any restriction, within reason. So I'll give you an example. Take Sony. If a Sony cable is 100 feet long, I would suspect you could hook a 100-foot cable to our system. So I would suspect that we adhere to the guidelines of the manufacturer. So the question was, how long of a camera control cable can I run to the base station? So I would say I would always encourage testing, but I would say that we would adhere to the distance that the manufacturer recommends. And then the same gentleman asked, what band does the camera control work on? It works on the same pipe. So if it's a 5 gig radio, ABonAir does not offer a 2 gig BAS solution. They have 5 gigahertz band from 4.9 to 5.9, and then they have 7 gig radios from 6.5 to 7.5 gig. Those are the 2 bands that they support. So the video, the audio, the camera control, the intercom are all going over that bidirectional radio. So it's all together. So it basically it's a duplex wireless pipe. It's not on a different band. What major events is the system currently working? Let me see. That's a great question. We started representing ABonAir in January. I think I don't see it there. There's a picture. Quite a few sporting venues. I can get you that. You know, the question was what major venues or events has the technology been used at? That's a great question. I'll make note of that. That will in the ebook that we publish in a few weeks. I'll just jot this down. Events and customers. I don't have that at my fingertips right now, but that's a great question, Mike. I guess that's it. Let me see here. Anybody else have any questions? I guess that's it. So we'll wrap it up. You know, if you guys think of any questions later here, let me put the slide up with my contact info. Let me jump to, start it over again. Let me jump to the end. So here you go. Here you go, guys. So jimj@vidovation.com is my email address. You feel free to email me any questions you might have. Also, you can reach us at 949-777-5435. That's our main phone number. We have a sales office in the Metro New York City area. My colleague Craig Abrams works out of that office, and my colleague Rick Anderson works out of the California or the West Coast office. We look forward to seeing all of you at NAB, and have safe travels to the show. And be sure to look for us online at vidovation.com, vidovation.com, and be sure to connect with us on social media. Thanks everyone so much. Really appreciate you guys taking the time to join us today, and we hope to speak with you soon. Thanks so much. Bye-bye.